Welcome to The Explainer. Today, we are diving deep into the absolute heart of AI development. We're going to look at the research that's shaping how we build these models, how we defend them, and, maybe most excitingly, how we unleash their power out in the real world. So, it really all boils down to this one single question. It's the question that keeps researchers up at night. It's not just about making AI smarter. It's this complex three-part puzzle. How do you build a model that's incredibly capable, fundamentally secure, and genuinely useful, all at the same time? Getting that balance right, well, that's the grand challenge. To really unpack this, we're going to look at three interconnected fronts. First, the actual architectural blueprints that make these AIs tick. Second, the new threats that pop up as these systems get more and more powerful. And finally, the incredible new abilities that are being unlocked because of all this. Let's start at the beginning with the blueprint. All right, first up, the blueprints of intelligence. You know, all the amazing stuff AI can do, it all starts with its fundamental design. And progress here isn't just about, throwing more data or more computers at the problem. It's about fundamentally re-engineering how these models learn and reason from the inside out.
So, researchers found this really weird problem lurking inside our biggest AI models. There's this crucial process called layer normalization. It's what keeps the training stable, but it wasn't working perfectly. One method, called pre-LN, made the early layers of the model super smart, but the deep layers, they were kind of slacking off. The other method, post-LN, did the exact opposite. It was like having a team where only half the players were on the field at any given time.
The solution they came up with is pretty clever. It's called MixLN, and it's basically a best-of-both-worlds approach. It strategically uses one method on the early layers to get them working hard and the other method on the deeper layers to wake them up. This makes sure the entire network is learning effectively, so you get a more capable model without just making it bigger. It's all about working smarter, not just larger. And this kind of smart architectural thinking is happening all over the place. You've got researchers looking at human memory for inspiration on how models learn. They're solving this huge problem called catastrophic forgetting, so a model can learn new stuff without wiping out its old knowledge. They're even figuring out how to make models pull up information faster, which is absolutely critical for the next generation of AI systems.
Okay, so as these AI blueprints get more and more powerful, a whole new front opens up. This is the constant battle between the people trying to exploit AI and the people trying to secure it. It's this high-stakes cat-and-mouse game where every single advance in capability accidentally creates a new vulnerability.
82.57%. Now, at first glance, you might think, hey, that's a pretty good score. But what if I told you that number actually represents a massive hidden risk in one of the world's most advanced AI models? So that number, that's the percentage of time that GPT-01, one of the top models out there, is factually accurate in its reasoning. This means for almost 1/5 of the time, it can get the right answer for completely the wrong reasons. Think about that. That is a huge hidden vulnerability. I mean, in fields like medicine or finance, a correct conclusion that's based on flawed logic isn't just wrong, it's incredibly dangerous. And this brings us to a much more direct kind of threat: jailbreaking. This is the word for when someone deliberately tricks a safety-trained model into spitting out harmful or forbidding content. And let me tell you, attackers are getting unbelievably creative. A recent paper actually showed just how creative. Instead of asking for something bad directly, an attacker just masks the request as a simple word puzzle. They ask the model to solve an anagram. The AI, which is, designed to be helpful, just solves the puzzle, and boom, it accidentally reveals the forbidden word. It's an attack that uses the AI's own helpfulness and intelligence against itself. And this is that endless game I was talking about. A new attack like the puzzle one emerges, and immediately researchers respond with new defenses. We see techniques that can restrict harmful outputs without retraining the whole model. We see other clever tricks to embed a hidden, robust fingerprint into a model, kind of like a digital watermark, to prove you own it if it's stolen. Every move just prompts a countermove. So, after improving the blueprints and constantly fending off attacks, what's the big payoff? Well, this is where it gets really cool. We're now at what you could call the dawn of autonomy.
where AI moves beyond just generating text on a screen to actually perceiving, planning, and acting in the physical world. Yup, this is where all that foundational research really starts to pay dividends. We're moving beyond chatbots and image generators. We are creating truly autonomous agents. These aren't just lines of code anymore. They are becoming systems that are capable of tackling complex, real-world tasks. And to make this happen, you need a whole new toolbox. For example, some systems are being designed to give robots a lifelong memory so they can learn and adapt over time. Others are all about teamwork, letting multiple AI agents collaborate on really complex missions. And others are tackling reasoning itself, helping AI handle facts that change over time or even verify claims by building logical arguments. Every single one of these is a critical building block for real autonomy. And this isn't science fiction. Take that teamwork framework, Eurosa. It's being used right now to create cognitive underwater robots. And we're not talking about some pre-programmed drones here. These are teams of AI agents that can see their environment, plan missions together, and adapt to whatever surprises the deep sea throws at them. It's amazing. At the same time, that memory framework, L3M plus P, is bringing this autonomy right into our homes. It's enabling service robots that can learn about your house just by talking to you and using their sensors, and then use that knowledge to actually get household tasks done. This is the big shift from specialized machines to truly general-purpose assistants. So we've got these three things: better architectures, new attacks, and this emerging autonomy. But they aren't three separate stories. No, they are all part of one single, powerful cycle that is driving all of AI innovation forward at an incredible speed. Here's how it works. It's like this never-ending loop. First, we develop new architectures, like that MixLN thing, that make models way more capable. Step 2, this new capability enables greater autonomy, like our underwater robots or the ones in our homes. But Step 3, giving AI more autonomy in the real world inevitably exposes new attack surfaces and new vulnerabilities, like the reasoning flaws or the jailbreaks we talked about. And that, Step 4, forces us to go right back to the drawing board to develop even better, more secure architectures. And the cycle just begins all over again. And this brings us to the final and most critical thought. This cycle of innovation, it's speeding up. Every loop gets faster, and the stakes just keep getting higher. So the question that we're all left with is this: as we push the boundaries of what's possible, who has the ultimate responsibility? The researchers, the companies, the governments? Who is responsible for making sure that the next thing we build is not only more powerful, but is also fundamentally safe and truly worthy of our trust?